Now, we go to another term of temperature. We already reviewed dry bump, and now what is dew point temperature? Dew là sương á, nhiệt độ điểm sương. The foggy point temperature. What is dew point temperature? We just move one slide. We look at this example and we can relate it better. Now we drink coffee. We put some ice in the cup. And after a while, what do we see? Appearance of drop of water on the surface of the cup. Why this happen? The temperature here, for example, is room temperature 30 degrees C. The relative humidity here may be 85%. What does that mean? What does that mean with 85%? That air contains 85% of the vapor can contain already, right? Now, if this air move nearer to the cup, what happened with temperature? The temperature will reduce. What happened with relative humidity? When the temperature reduces, relative humidity will increase, right? When we increase temperature, relative humidity will be decreased, but when we reduce the temperature, relative humidity become increase. Because when we reduce the temperature, then this one reduce. Okay. And then when it's here, maybe at 15 degrees C, the relative humidity become 100%. What is that state? How do we call this state? Saturated air. Now the air contains maximum amount of vapor it can contain. But now if we go nearer and nearer to the temperature of the cup here, maybe 4 degrees C, when the air is already saturated and you reduce further the temperature, what happened? Condensation. We will see later is clearer on psychrometric chart. Now you just try to imagine. Because at 15 degrees C, the air is already saturated, but now the temperature still go down, so it cannot go beyond saturated state. So vapor has to be removed from that air. Vapor is removed from the air means vapor become liquid. And how do you call this process? Condensation occur. And water is removed from the air. And actually vapor become liquid, and then their appearance drop of water here. And the temperature here, right at this position, is called dew point. Okay, dew point is the temperature that is become dew, is condensation occur. Another example, for example, in Dalat, why it is foggy in the morning, but at a bit like at 9 a.m. there's no more fog.
The amount of total water in the air is the same from the morning to noon. But what is different then?
Relative humidity at noon time, the temperature is 25. Maybe relativity here is only like 85%. What happened in the morning? The temperature in the morning is only like 15 degrees C. Now it's become, that air become already saturated. And then the vapor in the air condensate to become small droplets of liquid water. And this small one can just refract the light from the sun, and then it look foggy. Fog is actually the small droplet of liquid water. Because vapor in the air condensate into liquid because the relative humidity is already 100% when the temperature in the morning is lower. But then at 9 a.m. when the temperature rises up, the condensate, the fog will just evaporate again into vapor. So what is dew point then? When we just reduce the temperature of a current air to a certain point of temperature where the condensation occur, where the relative humidity become 100%, then that is the dew point temperature. The dew point temperature can be obtained from also the steam table, same table. For example, at water vapor pressure 2.064 kilopascal. This is partial pressure of water vapor. Then the dew point is also actually the thermometer of water. The water is 18 degrees C. It's also dew point thermometer. This is partial pressure of vapor, so the dew point thermometer is 18. There's another term of thermometer. It's also interesting. Wet bump thermometer. Wet bump thermometer. Nhiệt độ bầu ướt. How do we measure this? Here we have a normal thermometer to measure dry bump thermometer. Here also a thermometer, but now the sensor is covered with a wet wick, kind of close, and then here is connected to a small container of water, and they introduce an airflow 5 meters per second, quite strong airflow. What does this wick do? The wick is like a close woven like this, means it gives a lot surface area for the water to evaporate. When water evaporates, this airflow will blow that vapor away, and then new water just evaporate continuously, freely. And then the air surrounding this sensor will be saturated air. Why saturated air? Because water evaporates freely, and then the relative humidity of that point is 100%. It's content, maximum vapor is already contains. What then? The thermometer of the air, this one measures the thermometer of the air, right? The sensible heat of the air will be converted to the latent heat to evaporate the vapor. So the thermometer of this sensor will be a little bit lower than the dry bump. Because you lose energy, you lose heat to evaporate the water, so the thermometer drop down. What do you measure here is called wet bump thermometer. It's not only wet, but the evaporation is freely, okay? And the air, surrounding air of that bump is saturated, 100% relative humidity. So what do we see? The dry bump thermometer is higher than the wet bump thermometer. They call thermometer depression. In what case the wet bump and the dry bump will be equal? What do you think? What case then the dry bump and the wet bump will be the same? What condition of this air do you think? If we blow in the air, what condition of this air, then we have wet bump and dry bump together the same value? If this air is saturated, then water here cannot evaporate anymore because it's already saturated. It cannot uptake vapor anymore, right? And then that time the thermometer here also become wet bump thermometer already. So wet bump together with wet bump will be the same. Okay, when relative humidity is 100%, wet bump and dry bump is one value, and actually dew point is also the same. So when the air is saturated, dry bump, wet bump, dew point is one value. Good? Yes. Now we move to the next review part, the psychrometric chart.